Your Urschel machine was purchased to produce the best quality cut on your product. To maintain this quality, you must pay special attention to the cutting parts on your machine. This video will guide you through the proper maintenance of your knife assembly. For safety reasons, only personnel trained to work with knives and sharp edges should attempt the following procedures. The slicing knife, which makes the first cut on the product, is held in the slicing knife holder by a friction fit. To remove this knife, place the slicing knife holder on a flat, level work surface on its back edge with the knife facing upwards. Insert the small tip of the slicing knife remover under the notched corner of the slicing knife. Use the tool like a jack and pry the knife up an inch or so. Turn the tool over and, with upward pressure, force the knife further out of the holder. When the knife is out far enough for you to grasp it safely and comfortably, pull the knife all the way out of the holder. Before installing a new or sharpened knife, make certain that the slot in the slicing knife holder is clean so that the slicing knife will seat properly in the bottom of the slot. Check the bottom of the slicing knife holder for burrs and hone if necessary. Before installing a new or sharpened knife, make sure it is clean of all product and burrs. Slide the knife into the slot of the slicing knife holder. Make a cushion of clean shop rags long enough to protect the knife edge while you push down on the slicing knife holder, forcing the knife into the slot. Use the handle of a screwdriver or plastic hammer and tap the slicing knife in place until it is centered in the slicing knife holder. Press down on the knife again and make a final check to be sure it is seated all the way into the holder. To disassemble the circular knife spindle, secure it in a soft jaw vise at the gear end. Soft jaws are necessary to avoid damage to the precision parts. Do not clamp the vise onto the gear itself. Use the spindle wrench supplied with your machine and remove the nut. This nut has a right-hand thread and is removed by turning counterclockwise. Slide the knives and spacers off the spindle. The circular knife spindle requires little maintenance other than cleaning and changing knives. Before you reassemble the spindle, make certain the knives and spacers are clean of all product. Do not use an abrasive material to clean the spacers. It is important that you do not remove any metal from these precision parts. However, if a spacer has been dropped, check for any burrs and hone if necessary. Check the spindle for any product or burrs and clean or hone if necessary. When you're installing new or resharpened knives, make certain the serrations on the knife edges face in the same direction. You can refer to the chart in your operating manual for the correct number of knives and spacers for your spindle. Install the nut on the spindle and tighten securely. Remove the spindle assembly from the vise and check both ends of the spindle assembly for burrs and hone if necessary. If you are not going to install the spindle on your machine immediately, store it in a safe area resting on the gear end, never on the knives. Poor quality dices, product spillage, or crosscut knives striking other parts of the machine usually indicates internal wear of the crosscut spindle parts. Check for sideways movement of the crank and idler pins. A quick bench check after running, but before relubricating, will verify this. Rotate the shaft a few degrees each way and note if there is any free movement before the knives begin to rotate. If so, complete disassembly and a thorough parts inspection is the only way to determine exactly which parts need replacement. Place spindle assembly securely in support blocks or a block and table vise as shown here, and remove all knives. The procedures shown here are for the 7, 10, 12, 14, and 16 knife spindles. A separate video is available for the 22 knife spindle. The knife screws have nylon locking inserts which will wear out in time. Examine these screws carefully and replace them when the nylon insert fails to produce any drag or friction on the threads of the crank and idler pins. After you have removed all the knives, secure the spindle in a soft jaw vise. Clamp the vise onto the central spool with the gear down. Do not hold the spindle by clamping the vise onto the gear. This will damage the gear and cause noise and excessive wear. Hold the spindle shaft to keep it from turning and remove the grease fittings. Use a strap wrench or soft chain wrench and remove the end cap. A strap wrench is recommended to avoid potential damage to the parts. The end cap has a right-hand thread and is removed by turning counterclockwise. The crank bearing is now exposed. What you see here is an example of extreme wear between the eccentric and the crank bearing block. Next, lift off the crank bearing block and remove the crank pins. Reverse the spindle assembly in the vise. Remove the 3 socket head cap screws in the gear and remove the gear. If the gear does not lift off, pry it up gently with a screwdriver. Remove the 3 socket head cap screws in the drive cap. Insert 2 of the fasteners into 2 of the holes provided for the gear fasteners. Using these screws as jack screws, the drive cap can be backed off the spindle assembly. Remove the idler pins and clean all parts thoroughly before your parts inspection and spindle reassembly. We recommend that you partially disassemble the spindle every week or 2 for a thorough cleaning because juices from the product will seep into the ends of the knife bearings and, if ignored, will cause corrosion and wear. You should at least remove the 2 end caps. To perform a thorough parts inspection, you will need micrometers, a telescope or bore gauge, and a small hole gauge. Mic the eccentric. Replace if outside diameter is under 1.9352 inch or more than 0.002 inch out of round for Model G series. Model F limits are 1.5532 and 0.0015 inch. Mic the diameter of the shaft. Replace the shaft when the diameter measures below 0.998 inch, Model G, or 0.7477 inch, Model F. Use the telescope gauge and micrometer to check the diameter of the center bore of the crank bearing block. Replace when greater than 1.9412 inch, Model G, or 1.5577 inch, Model F. Use the small hole gauge and micrometer and check the diameter of the holes in the crank bearing block. If any hole measures over 0.3757 inch, the crank bearing block must be replaced. You will notice a wear pattern develop on the idler pins. Mic the diameter and replace any idler pins that measure under 0.372 inch. A similar wear pattern develops on the crank pins. As with the idler pins, replace any crank pins that measure under 0.372 inch. Check the center bore of the bearing block bushings. If this measurement is greater than 1.0033 inch, Model G, or 0.7527 inch, Model F, replacement is necessary. Also check the small holes in the bearing blocks in both ends of the spindle. If any hole measurement exceeds 0.3757 inch, the bearing block must be replaced. Examine the gear for signs of damage to the teeth. If the damage is not too severe, teeth can be filed smooth and the gear reused. We strongly recommend that spindles be returned to us for bearing block replacement. However, if your maintenance department has the skill and recommended equipment, proceed as follows. The toolkit shown here can be ordered from Urschel Laboratories and is specifically for bearing block replacement. It includes a support tube, pusher block, tap, bolts, hex key wrench, installation pins, installation rods, and a chain wrench. Also required but not supplied is an arbor press, surface plate and dial indicator, vise, torch, brass hammer, thickness gauge, hone and file, and a depth micrometer. Use a 7/16 inch diameter, 14 threads per inch tap to thread 2 opposing holes in each bearing block. If you're using a 22 knife crosscut spindle, use a 3/8 inch diameter, 16 threads per inch tap. Using the appropriate set of holes, attach the pusher block to one of the bearing blocks. Slide the spindle shaft down through the spindle to contact the pusher block. Position the spindle with the pusher block down onto the support tube on the table of the arbor press. Press the bearing block out of the spindle. Repeat this procedure on the other end of the spindle. Check the drive cap for nicks or burrs and hone or file if necessary. Check the end cap for nicks or burrs and hone if necessary. Remachine or replace if dimension exceeds 0.946 inch. Measure from edge to inside face. Bearing blocks must fit tight into the spindle. If old blocks are loose or the new block slides freely into the bore, the spindle is scrap and must be replaced. Using a surface plate and dial indicator, check the ends of the spindle for parallelism. If it is more than 0.002 inch out of parallel, the spindle must be straightened or replaced. We recommend that bent spindles be sent to the Urschel Laboratories Repair Department for inspection and evaluation. With the threaded end down, set the spindle on a smooth, flat surface to install the bearing block. Insert 3 installation pins into 3 somewhat evenly spaced holes in the bearing block. Snug the nuts just to retain the pins. Set the bearing block, complete with the installation pins, onto the spindle so that the ends of the installation pins are set in the holes in the spindle. Make certain the bearing block is in the correct position with the flat side facing down. Rotate the spindle slowly by hand while applying heat with a propane torch 1 inch below the top of the spindle. The spindle will expand from the heat and the bearing block will drop in. If the bearing block starts to drop in but does not seat properly, allow the spindle to cool, remove the bearing block, check the parts for nicks and burrs, and repeat the procedure. Remove the heat. Use the handle of a hammer or screwdriver to apply downward pressure on the bearing block for at least 1 minute. If the bearing block does not drop in after applying heat for 1 minute, press down on the bearing block with the handle of a hammer or screwdriver after the bearing block starts to sweat oil. Carefully remove the installation pins. Check with a .0015-inch thickness gauge to make sure the bearing block is seated properly. The gauge should not slip between the parts. To install the remaining bearing block, turn the spindle over and insert the installation rods into 3 somewhat evenly spaced holes. Slide the bearing block onto the installation rods until the bearing block rests on top of the spindle. Make certain the bearing block is in the correct position with the flat side facing down. Rotate the spindle slowly by hand while applying heat with a propane torch 1 1/4 inch below the top of the spindle. The spindle will expand from the heat and the bearing block will drop in. If the bearing block starts to drop in but does not seat properly, allow the spindle to cool, remove the bearing block, check the parts for nicks and burrs, and repeat the procedure. Remove the heat. Use the handle of a hammer or screwdriver to apply downward pressure on the bearing block for at least 1 minute. If the bearing block does not drop in after applying heat for 1 minute, press down on the bearing block with the handle of a hammer or screwdriver after the bearing block starts to sweat oil. Carefully remove the installation rods. Check with a .0015-inch thickness gauge to make sure the bearing block is seated properly. The gauge should not slip between the parts. The eccentric is held on the shaft by a roll pin. To remove this pin, secure the eccentric in a vise and drive the roll pin out with a proper size pin punch. To install the eccentric on the shaft, make sure the side containing the shoulder faces the long end of the shaft, and the side marked "this side out" is facing the short end of the shaft. Drive the roll pin in place until it is flush with or slightly recessed below the top of the eccentric. To assemble your spindle, place the spindle in a soft jaw vise with the idler end up. The threaded side will be down. Lubricate the idler pins and install them in the bearing block. To lubricate spindle parts, We recommend Haynes Lubrifilm or the equivalent. Install the drive cap and fasten with 3 5/8" long socket head cap screws. Lubricate the center hole of the gear and the bearing block. Install the gear on the drive cap and fasten with 3 1-inch long socket head cap screws. Reverse the spindle in the vise. Lubricate the crank pins and install them in the bearing block. Install the crank bearing block. To make sure this part is installed properly, look for the assembly mark which indicates the side facing the spindle as it is installed. Lubricate all holes before installation. Lightly lubricate the outer perimeter of the eccentric and the grease grooves on the shaft. Install the shaft and rotate it by hand to make sure everything is seated properly and that there is no binding of the parts. Install the crank cap on the spindle and tighten with a strap wrench. Place the spindle assembly and supports on a flat, level work surface and install the knives. When you're installing knives, tighten down the screws, then back them off a quarter turn. After all the knives have been installed, mark your starting point on the spindle. Rotate the spindle a few times to seat the knives in place, and tighten the knife screws the rest of the way. Install the grease fittings in the ends of the spindle shaft with points facing the back of the knives. Place a pin through the spindle locating hole to prevent the spindle shaft from turning while you're tightening the grease fittings. If the grease fittings are installed incorrectly, your spindle cannot be lubricated with the hinged knife assembly in the operating position. The crosscut spindle assembly is now complete, and you can install it on your machine or place it in a safe storage area until needed. We've just shown you how to replace knives and repair your spindles. For further information on keeping your knives in top condition, refer to the Sharp Bulletin or the separate videotape we've prepared about honing knives. If the knives are not kept sharp, your product will be torn rather than cut, resulting in a poor appearance of the strips or cubes. An abnormal amount of fines and chips in the cover above the circular and crosscut knives and beneath the machine is a signal that the cutting parts are in need of maintenance. Your machine will let you know when it needs help. Pay attention to it. Establish a regular maintenance schedule for the knife assemblies. Because of the wide variety of products being processed on Urschel dicers, personal experience with your machine and product will help guide you in establishing this schedule. When ordering repair parts, you should supply us with the machine, model, and serial number, the quantity desired, the 5-digit Urschel part number, and a brief description of the part. This information will help us serve you in the quickest, most efficient way possible. Urschel Laboratories has been producing quality food processing machinery since 1910. With the proper care, your Urschel machine will produce the highest quality food product that is possible.